Okay, this will be the water cycle part 2. The water cycle. When you look at the Earth from space, there seems to be a lot of water covering its surface. About 97% of the water is salt water. Only 3% of it is fresh water. And more than half of that fresh water is frozen in ice caps and glaciers. Will we run out of water to drink? The good news is that new fresh water is created from the ocean by the water cycle. The movement of water. The water cycle describes the movement of water on the earth. It is the loop that has no starting point. The sun heats up the water in the oceans, causing some of it to evaporate as vapor into the air. You can see evaporation happen before your eyes. Place a bowl of water outside on a hot day and watch it disappear into the air. Sea surface temperature, surface winds, and air temperature all affect evaporation at the ocean surface. And here is a picture of the water cycle. If you want to see it a little bigger, you could increase your screen. And it shows evaporation, condensation, precipitation, groundwater. And if this picture is a little blurry, then you can also Google it and you will be able to see a better picture. The water cycle involves the movement of water on, in, and above Earth. Clouds form as cooler atmospheric temperatures, which means air temperatures, cause water vapor to form into droplets. This is called the condensation. Water particles grow when they collide. So we have some water droplets, and what happens is when they two bump into each other, they then make a bigger water droplet. When the droplets are large enough and the clouds get heavy, these particles fall to the earth as precipitation. It comes in the form of rain, snow, sleet, or hail. Rain is falling water in liquid form. Snow, sleet, and hail are falling water in solid or frozen form. Some precipitation falls on land. It is stored in snowpacks, lakes, reservoirs, and underground. So a reservoir is just a man-made lake. Most water that falls onto the land stays for weeks or even longer. While the water is on the surface, we can drink it or use it to grow food. Eventually, the water will evaporate into the atmosphere or return to the ocean as surface runoff. Some water also moves underground. This process is called infiltration. This water is pulled down by gravity and moves down through the soil and bedrock. Eventually, it replenishes aquifers, underground rock that can hold water. So you kind of think of a lake that's underground, maybe. So here is a graph or a picture. It says various types of precipitation when the weather gets warmer. So warm air has rain. Warm air can have freezing rain, sleet, and then snow. You can see this is the air temperature as it's getting less and less warm air. So snow has absolutely no warm air at all. And when I say warm, I don't mean hot, like you're going to run around in a shorts and t-shirt. I'm just saying above freezing. A changing cycle. There is a lot of precipitation in some parts of the world. In other places, rain or snow is scarce, which means hardly any. Precipitation varies with the seasons and from year to year. Water cycle variability, which means it's the way it changes, can cause unusually dry, which is a drought, or wet, which is flooding, conditions. Variation like this can be devastating to humans, animals, and the land. This graph did not copy over well. It says precipitation on land can vary. Regions can experience more or less rain than they usually receive. And this happens in Indianapolis all the time. Some springs we will have a ton of water. Some summers we'll have a ton of water. It's rainy almost every day. And then there's some summers where we have no rain at all. And just like this past winter, we didn't have that much snow, but in a few winters ago, we did. We had inches upon inches of snow. The water cycle also changes over longer periods of time. Earth can experience a cooler climatic period. During this time, ice builds up in ice caps and glaciers. During the last ice age, for example, glaciers covered 1/3 of the Earth's land. This caused oceans to be 40 feet lower than what they are today. When there is a warmer climatic period, ice caps are smaller. And we talked about this a lot in 4th grade last year. Distribution of Earth's water. This is a graph here you can look at if you would like. Data from satellites, which are from in outer space, help us understand how water is distributed on the Earth. So as you can see, most of our fresh water is in lakes. Then we have some swamps and then some river. For our fresh water here, we have ice caps and glaciers and groundwater and just Earth's water in general. 97% is ocean and 3% are fresh water. So if you were starting here, you take all the water, and then out of that fresh water, this is what we have. And then out of this groundwater here, because we can't drink ice caps and glaciers, this is what we got. All right, last paragraph. NASA satellites observe and measure the water on land, in oceans, and in the atmosphere. This information helps scientists understand how much water is available. Measurements like these can help scientists see changes in the Earth's water cycle. Many scientists dedicate their lives studying the water cycle because it is so important to our lives. And that is super true. If you remember when Mr. Crosland came in, we can only survive, I think what was said, 3 days without water. So anyway, we're going to go over the questions next.